Hi, this is Ro of the Dr. Vax channel. And as we approach the end of the year, I'd like to ask a deep philosophical question. At what point does an Ender 5 cease to be an Ender 5? So my Ender 5 here has more than half a dozen upgrades. It has reinforcement, 3D printed reinforcement brackets on the bed. It has a layer lock print surface from Matter Hackers. It has a micro Swiss hot end. It has Capricorn tubing. It has upgraded firmware. It has an easy ABL auto bed leveling system. And it even has a replacement extruder from CME CNC. Now, it still feels like an Ender 5 to me, but I'm going to take it further. I'm going to replace the main control board in this Ender 5. At which point, well, it will still be a Bowden style printer, and it will still have the stepper motors and the frame and the power supply supplied by Creality. Effectively, everything else will be changed. And so I will argue that, in fact, perhaps this will no longer be an Ender 5. But a more important question is, if you're going to do all of these upgrades, which are hundreds of dollars, this board alone is $100. Yes, you can get less expensive boards. We'll talk about that in a moment. And then spend tens of hours, depending on your skill level, hundreds of hours upgrading an Ender 5? Does it make sense? So we're going to cover all of those topics today as we close out the year. Stay tuned and let's learn something together. Okay, I'm back with the Ender 5 on its side and the back removed. We'll need to be able to get to the existing controller board to replace it. Well, one note, when you go to remove this back, please note that there's a cable to the fan. That cable plugs into one of the power connectors on the existing controller board, and you want to take that off carefully to make sure you do not break this wire or break your board when you're going to take it off. Now let's talk a little bit about the TH3D EZboard. This is the EZboard Lite. Why did I select this board? I could have selected a Duet 2 board or a Duet 3 board, potentially for less money with more capabilities. The Duet style replacement controller boards have Wi-Fi or Ethernet capabilities that this board does not have. So why did I select this board? I selected it because it's a plug-in, drop-in replacement for the existing board. You literally take the cables from one board, you put them in the exact same places. The screws that hold the board onto the case are in the exact same places. So it's a very, very easy upgrade in an area that's a little bit scary. That's a hard upgrade. You're replacing the main electronics in your 3D printer. What other reasons did I select this board? Well, I've used the TH3D version of Marlin, which they call their unified firmware, before. That's what's running on this Ender 5 already. So I was already familiar with that. In the case of the EZboard, they've made it even easier. I had to compile the version of Marlin that I have in this printer now on my Mac. They now have a website you go to where you specify your parameters and you compile it online and download it, and then you can load it into the board. These boards come already prepared with a bootloader, so you're ready to go. Now, what is the difference between this board and the board that's already in the printer? Well, the first difference is it's quite a bit faster. This uses a 32-bit processor chip versus a 16-bit processor chip. This has substantially more memory space. This runs at, let me get this right, 120 megahertz. This processor board runs at 16. Another difference is we're going to go from Marlin version 1.6 to Marlin version 2.0 because there's more space on this board and it's supported by 2.0. Finally, this printer should run quite a bit quieter and the quality might improve a bit. The stepper motors in the Creality printers are considered noisy stepper motors. That causes artifacts, electrical signaling challenges that can cause artifacts on your printer. You'll see those as ghosting and other types of artifacts. One way people eliminate those artifacts is they put something called TL smoothers, which are little diode boards that are used to help smooth out the electrical current voltage going back and forth to the stepper motors. And by smoothing out that electrical process, that electrical power, you take and eliminate some of those artifacts. This board has Trinamic TMC 2208 drivers in it. That's these chips here. Now, why does it matter? Well, first of all, the drivers are more sophisticated. They're able to move the stepper motors in smaller increments more smoothly. That will make the motors quieter. But they also have the equivalent of TL Smoother technology built into the driver chips. Now, one difference you'll notice between these boards is the original Creality board has a whole bunch of heat sinks on it. This board doesn't. Why? This is just a higher quality board. This is a 4-layer circuit board with more copper in it. So this overall is a higher quality product than the standard boards you get in your Creality printer. This board is available online for $99, $99.99, $100, I guess, at TH3D directly. Okay, so I'm going to unscrew this board, take the connectors out, put them into the new board, and then we'll come back and we'll look at upgrading, downloading the 2.0 Marlin firmware to this board. I'm back after installing the EZboard into this Ender 5. Here's the original Creality board. They look, as I said, very similar, except once again, these have heat sinks because this is a 2-layer board. The new EZboard is a 4-layer board, so it does not require the heat sinks. The pads on the back and the metal in the board itself is enough to act as a heat sink. I must tell you, this was remarkably easy. I've always been a little bit queasy about replacing major electronic components. Yes, I have a computer science degree. It's from the age of the dinosaurs with mag tape and punch cards. But in spite of the fact that I have an engineering degree from an engineering school, when I go to turn on a switch after I've installed a new electronic component, I always expect to see a flash of blue smoke. That didn't happen. This was very, very easy. The trickiest part of this is these connectors on both sides, where the ribbon cables, the cables for the various sensors connect, have a little bit of hot glue over the edge of the connector and the socket. You need to take a needle nose pliers and carefully remove that hot glue before you attempt to pull out the connectors in the old board. You don't need to put glue on the new boards. That's really because these are shipped around and bounced around, helps keep the sockets, the cables in place. So the installation was very, very simple. Let me go to the screen now and take you through the steps that I went through. And then I'm going to show you some pictures of various steps. We'll talk about the process a bit more, and then I'll tell you my impressions of using an EZboard in my Ender 5. After installing the board, I verified that the board worked by actually powering it on. Yes, you can turn on the printer before you load the firmware. There's an indicator light on the board itself that'll tell you it's getting power, and the LCD panel will come up with a test message. I'll show you a picture of that in a minute. Then I went to the TH3D firmware configuration site, and we'll show you what the steps are there. That's a remarkable advancement. The site is not beautiful. I have some security concerns. Your configuration.h files, your configuration files are really public. It's not protected in any way. It's basically an online server that will create a binary file from your configuration, and your configuration is public to anyone that goes to the site. Now, there's nothing in my configuration that I really care about. I'm not hiding passwords or anything in that configuration. But it might be nice at a future date just to make people feel a little more comfortable if TH3D added a password to each configuration of some type. Either way, you go to their website and you can build the Marlin firmware for your printer. You don't have to install any software onto your Mac or your PC. You don't have to build the software locally. You don't have to learn about software development tools. Just go to a website and I'll show you how that works. Then you load that file onto an SD card. Standard SD card, one of these small SD cards that I always lose. You do need to use a smaller SD card. I think the documentation says under 32 gigabytes. There have been some issues. If they're larger, I happen to have an 8 gigabyte card. Now, in this control board, just like in the original Ender control board, the SD cards go back in upside down. You then power on your printer. It will read the firmware.bin from the SD card. It will load it to the flash memory and you are ready to go. But not quite. Because if you look here on the screen, you'll see I did a number of additional steps. This Ender 5 is not a stock Ender 5. It doesn't have a stock extruder, doesn't have a stock hot end, and it has an auto bed leveling system. So I had to configure those. I had to calibrate those. So I did a PID auto tune to calibrate my all metal hot end. I used a test print and calibrated the Z height, the Z offset for my auto bed leveling. And I did a real quick test of extrusion. I need to spend a little more time on that to calibrate my CME CNC Easy extruder that I have on this printer. Once those things were done, I went ahead and I printed some test prints. And I will tell you that it worked perfectly. Now, what I did notice, I was expecting to be able to test both speed and quality. But using the profiles that are relatively slow profiles at 50 millimeters per second, all the print speeds came out about the same. And the quality came out almost identical. Maybe slightly better, but I was already getting very good quality on this Ender 5. So I think what I'll find is because of this new control board, and I'll explain why in a moment, I'll probably be able to get better quality in the future at higher speeds. Now, let me show you some pictures of what happened along the way. Here's the first screen that comes on when you first turn on the board. It's followed by this screen. And then the third screen indicates it thinks this is an Ender 3. That's because this is the test firmware at this point. I haven't flashed the new firmware yet. And scrolling across the bottom is a message that says, do not try to print to this printer. It doesn't have the right parameters set up for your printer. After doing that, you go to easyfirmware.th3dstudio.com and you really have 3 ways that you can configure your firmware. You can download a configuration.h file and edit it with a text editor. I use the Atom text editor. That's the approach I use. And I'll show you what that file looks like in a minute. And that's where you set the parameters, where you set the definitions that indicate what printer you're using and what features. In my case, an Ender 5, using an Easy ABL auto bed leveling system. Then you upload that configuration.x file back to the website. Or you can use an online editor to edit that file. Or the folks at TH3D made it even easier. You're not comfortable with editors? Well, you can bring up a form and you answer a bunch of questions and it will create the configuration.h file for you. At which point, it will begin to build your binary firmware file. So let's take a look at my configuration.h file. You'll see I've defined it as an Ender 5 and I've defined that I have an Easy ABL. Those 2 lines are dark black because I've removed the slashes. Slashes in this configuration file indicate a comment. I submitted that, and then I saw a screen like this. It took about 2 minutes to build my binary file, and then gave me an option to download it. I then took the SD card, I put it into the printer, I turned on the printer. It took about a minute or so to flash the flash memory in the printer, and then came up to the standard Marlin TH3D firmware screen. And it's running specifically Marlin 2.0. Now, there are a number of features in Marlin 2.0. You can see those all on the screen here, but there are really two general characteristics that are most important to me. The first is that they've added filament loading and unloading, and they've enabled it in this build. That makes it much easier. So basically, you load your filament into your extruder, you push it through so it's just before your hot end, and then you can use commands on the console to load it the rest of the way. It'll bring your nozzle up to temperature. It will extrude or purge segment of filament because you may be changing color. It'll give you an option to extrude more. Works very, very well. The second one, which is really even more important, is that many of the parameters in Marlin that you had to edit manually and then rebuild your firmware and flash your firmware in order to use in the past are now available in 2.0 right from the front LCD panel. So as an example, it always bothered me that the preheat PLA setting would preheat to 200 degrees centigrade. I don't think that's hot enough. I think if you're loading a new filament, you want to make sure you push out anything else that's in there. You want it to be a little hotter. I like to go to 210. You can change that right from the front panel. You can change your acceleration parameters. You can change your jerk parameters. These are all available right from the front panel. So Marlin 2.0 is a nice addition, in addition to all the other things you see on the screen here, that it has support for a wider range of boards, power fail recovery. It supports more of the trinamic drivers, which are very important. Heated chambers up to 6 extruders, ... But for me, it was the ability to change configuration parameters from the panel, which was really a welcome addition. Now, what did I notice when I turned on this printer? Well, let me show you. If you look at this picture here, you'll see that this printer was running about 67 dB before I replaced the control board. It's now running almost 10 dB quieter. Now, 10 dB is about double the sound level, or what you perceive as sound. So if something's 10 dB louder, it sounds twice as loud, or 10 dB softer, it sounds half as loud. I will tell you, it's magical. I didn't think it'd make that much difference because there are a lot of moving parts here. But what's interesting about the Ender 5 is because it uses these sort of rubbery plastic nylon wheels here, which is a very different system than, let's say, my Prusa, which uses metal bearings. You don't get a lot of noise from these wheels. All the noise that was coming from the printer was the actual stepper motors. I would have never believed it. When this is printing, it's quiet. It's like having a softly blowing fan or room window air conditioner in the room. You don't hear the printer. It is now the quietest printer I have in my shop, much quieter than the Prusa i3 MK3. But what's also interesting is the print motion is very, very smooth. Let's look at this video for a moment, and you'll see how smooth the print motion is. Because the print motion is very smooth, in spite of the fact that initially I didn't really see any speed difference or any quality difference, I expect that I can run this printer much faster as I tune the profile with the same quality. So, am I happy with the EZboard? So far, I'm very happy. I really can't tell you how much of an impact the quieter stepper motors makes, but that and the smoothness of the motions are rather dramatic. Let's wrap this up. This printer is now twice as expensive as an Ender 5 that you buy from the Creality site online. It has an EZboard for $100, a CME extruder for $35, Capricorn tubing, which is about $11, a micro Swiss hot end, and I have the hardened nozzle, which was $84 altogether. Easy ABL, $68. I have the layer lock print surface, the removable print surface, which is spring steel and is powder coated, which I really like. It's just $50. I have the 3D printed supports that I added to this printer in a couple different places. So altogether, this is about a $680, $690 printer. Is it worth it? Most of these upgrades probably are. And this printer can now print at higher temperatures, probably faster, much quieter than any other printer I have in the shop other than the Prusa i3 MK3, which is louder, but I still don't know about speed. Historically, that printer's been about 30% faster than this printer. That's what I have to test now. So folks, I hope you learned something today. If you did, please give me a thumbs up. Share this video on social media and Facebook, online and Twitter. You're welcome to share it anywhere you'd like. Just share the URL. Subscribe to the channel, and let's continue to learn things together.